This is the session on automating secure. Oh, I did not turn on my mic. You can hear me? Yes. Oh, can you double check? Am I on now or? Yeah, okay. All right. Thanks. So this is the session on automating secure OIDC-based cross-cloud authentication. My name is Borko. Just a quick introduction about me. I'm a software engineer based out of Ottawa, Canada. I enjoy running. I often go on early morning runs along the Rideau Canal that's pictured here. I listen to a lot of podcasts. One of my favorite podcasts is Stuff You Should Know. I highly recommend it if you're interested in learning random trivia. And I used to study physics, so I'm very passionate about all things physics or science related. So the key takeaways from my talk are we should not be using access key IDs and secret access keys when accessing AWS in production or environments that require high degree of security. A better approach is to use OIDC for secure system-to-system authentication, and we should leverage automation at scale to improve security and reliability. So I'll begin with a quick review of the AWS IAM service. It provides centralized identity and access management. So it provides us capabilities for creation and management of user identities. So I'm referring to things like users, groups, and roles within AWS. Permissions in AWS are granted through IAM policies that define what actions are allowed on specific resources. And IAM roles are used to assign these permissions to groups or users. Fine-grained access control helps us implement the principle of least privilege by ensuring users have permissions that are only needed for their specific role. IAM integrates with external identity providers, so things like Microsoft Entra ID or Okta to enable single sign-on. It supports both SAML and OIDC for federating access to AWS, and this reduces the need for separate AWS credentials and improves security with centralized user management. Finally, AWS IAM enables issuance of temporary security credentials through AWS Security Token Service, and temporary credentials are automatically revoked after a set time, reducing the risk of stale access permissions. So access keys are used for programmatic authentication to AWS, so I'm referring to things like the API or AWS CLI or SDKs. So there are two components for access keys. We have access key ID, which is public, and then we have a secret access key, which is private and must be kept secure. So you can think of these as a username password pair, and they allow you to programmatically authenticate to AWS without the need for console credentials. So here I have an example of a AWS credentials file. So if you've used AWS CLI, we have configured this to enable access to your AWS account. And we have a dummy example of access key ID and a secret access key. So after reviewing that, we should not be using access keys when authenticating to AWS. These are long-term credentials that can be compromised if exposed or mishandled, leading to persistent security risks. They're against prescribed AWS security practices coming from AWS. Managing access keys across multiple users, services, and systems becomes complex and challenging as environments grow. Access keys are a lot harder to track and audit compared to IAM roles. In corporate environments, enterprise policies will dictate and prohibit use of access keys as well. And if your corporation or company does business in regulated environments, your business regulations will also dictate that you do not use access keys. Additionally, access keys are tied to specific IAM users, so that means that we cannot use RBAC to only assume roles needed for specific use case. So better approach is to utilize OIDC. So OpenID Connect is an authentication layer built on top of OAuth2, enabling identity verification using token. So these tokens have claims, which is information by the user, as well as scopes, which is information by the permissions that the user may have. So this allows us to implement fine-grained authorization in applications by controlling what data user can access based on their identity. OIDC tokens are short-lived and can be dynamically scoped, reducing the risk of stale or overly broad permissions that are common with IAM access keys. It allows applications to authenticate users via external identity providers like Microsoft Entra ID. And OIDC is commonly used for single sign-on, allowing users to log in once and access multiple applications. It reduces the need for separate credentials in AWS IAM. So it provides us a more secure and scalable user authentication compared to long-term AWS IAM access keys, which are prone to exposure and management overhead. So AWS provides us OIDC functionality through its AWS IAM OIDC provider service, which allows external identity providers like Microsoft Entra ID to authenticate users to access AWS resources. It enables federated access, allowing users to sign in using their credentials in those external IDPs without needing separate AWS IAM user accounts. So it's useful scenarios where we want to grant access to external parties, for example, external contractors or third-party services, to access AWS resources without needing to provision IAM user credentials in our AWS account. It reduces the risk of credential leakage by using short-term tokens instead of long-term IAM access keys. And IAM web identity roles are used to grant permissions to external entities into our AWS environment. So Microsoft Entra ID is Azure-based identity provider. Formerly, it was known as Azure Active Directory, and it's a comprehensive cloud-based identity provider, providing us capabilities for the full management of lifecycle of users, such as provisioning and deprovisioning of users and management of their access permissions. It has a comprehensive suite of governance and security features, such as conditional access policies, multi-factor authentication, advanced reporting, and additionally, it provides federated access enabling SSO via SAML or OIDC. And it allows us to create application registrations within Entra ID and configure their OIDC. So we can take these two components and come up with a integrated solution to enable OIDC authentication into AWS environments. So we would start by registering an external application, for example, your CI/CD system inside Entra ID. That client application can then log into Entra ID, and upon successful login, it would obtain an Entra ID token. Then it can use that token, the Entra ID token, to contact AWS STS and exchange it for a AWS STS temporary token. And then finally, using that AWS STS token, the application can assume an IAM web identity role and gain permissions to perform actions inside the AWS environment. So this whole solution is enabled by a trust relationship that's developed between the AWS IAM OIDC provider and the app registration inside Entra ID. So there are three configuration steps needed to implement this. Number one, we need to create an application registration inside Entra ID. Number two, we need to add the audience value to the AWS IAM OIDC provider. And number three, we finally need to create an AWS IAM Web Identity role. So this is a screenshot of how we create an application registration in Entra ID. Once we create our application, we would be given an application or client ID that's given here. We would use that value as the audience value when configuring our AWS IAM OIDC provider. And then finally, we would create a IAM Web Identity role for our OIDC provider, specifying the audience for our application registration. And then this shows the trust policy that basically creates the trust relationship between the web identity role and the application registration inside our Entra ID. So there are several challenges with manual configuration in enterprise environments. Namely, it can result in violation of security policies and compliance policies, because when done by different individuals, it can result in varying approaches and setups. Also, this solution requires substantial access privileges in both AWS and Entra ID, both of which are very important services in your landscape. So this can potentially lead to significant security risks. Also, it requires deep understanding of both of these platforms, which can be, the competence for that can be difficult to find in people, considering they're both in different cloud providers and can require a substantial additional training. And finally, manual configurations are always error-prone. Also, enterprise organizations use multiple AWS accounts for various purposes. So you will have things like logging accounts, networking accounts, security accounts. Various business units may have their own organization units and their own AWS accounts. You will have different environments such as dev, test, staging, prod, and these are often broken into many different multiple AWS accounts. And additionally, you may have temporary accounts for developers, sandbox environments, or proof of concept use cases. So many organizations use things like AWS Control Tower or AWS Landing Zone Accelerator or other automation pipelines to programmatically create AWS accounts at large scale. In these scenarios, this automation can create the AWS IAM OIDC provider in each account. However, there still needs to be additional automation in order to configure the OIDC properly. So this solution shows a comprehensive solution to implement automation for OIDC configuration. So on the left, we have just a sample account A that's newly created account via our automation. On the right, we have a centralized account that can contain our OIDC configuration factory. So the whole process starts with the creation or deletion of a AWS IAM Web Identity role. That event is recorded in AWS CloudTrail. We can have then event bus event rule that filters and captures that event. And then the two accounts are connected via event buses. And then in our factory account, we'll also have an event bus rule that will filter the events that we want and capture them, and then trigger a Lambda function. This Lambda function is responsible for invoking one of two state function workflows. So the first workflow is, well, I'll just review quickly both of them. The first workflow is is concerned with the events related to the creation of IAM Web Identity roles. The second workflow is concerned with the events related to deletion of IAM Web Identity roles. So taking a closer look at the first workflow, it has 3 Lambda functions. The first Lambda function invokes Entra ID API to register a new application in Entra ID, and it returns an audience identifier for that application registration. The second Lambda function is responsible for taking that audience identifier and adding it to our IAM OIDC provider in account A. And then the final and third Lambda function is responsible for updating the trust relationship in the IAM Web Identity role to add that audience identifier. So this step is needed because unlike in the manual setup, when we create the web identity role, we don't have the audience value yet. So we just put a dummy value, but then this automation will update that value a few seconds later. And then the second workflow for the deletion of the web identity role only has 2 Lambda functions. The first Lambda function just invokes Entra ID API to delete the existing app registration. And then the second Lambda function removes the audience identifier from the IAM OIDC provider. Okay, so to summarize again, the key takeaways are: in production or high secure environments, do not use access key IDs and secret access keys. Instead, a better approach is to use OIDC to enable secure system-to-system authentication. And at scale, we should be leveraging automation to improve security and reliability. So I have a few minutes left, so we can go through a quick demo. Hopefully it all works. Okay, so here I have my Entra ID and my identity provider for my Entra ID. So I begin the whole process by creating, okay, this is a little awkward, by creating a role. And we're going to create a web identity role for my Entra ID, and we are selecting a dummy value, as I mentioned. Great. Okay.
It's just very secure.
Okay, and then we'll just grant it, let's see, view only access permissions here. So as you can see here, this is dummy value in the trust policy. Oh, I need to give it a name. Okay, so we've created the dummy role in our account A. I'm going to switch now to my centralized account. So if I go to step functions here, and I take a look at my creation step function, it ran. So there were 3 steps here. So that means there should be a app registration now created. There we go. And then if I go back to my account A, and if I go to IAM, and identity providers. There we have the client ID has been added, and then I check my role, and we should see that the trust policy has been updated as well. Okay, and then yeah, so all that code is on my GitHub. It contains the source code for implementing everything in the factory. So there's Terraform code for all of the resources, IAM policies. There is code for the step functions and the Lambda functions. This presentation is available on my GitHub as well, and there is additional info if you want to connect with me. Thank you very much. Right. Are we taking questions? Yeah.